There's a plan in everything, kid. And I love it when a plan comes together.
The things I go through for the Name That Movie game. Alright, last video we talked about how to add that prediction line. Let's talk about how accurate your predictions are going to be. Notice on the data set we were just looking at, the red line represents what we expect. If you have a leaf size of 80, we expect O2 values to be, if I was eyeballing it, about 145-ish. But the dots don't land right on the red line. There's some that are really close, but you never get perfectly accurate predictions. So the question is, how accurate are they? Go back to the summary fit. See this 14.02 right there? That is a measure of how accurate we are with the regression line. Those data points tend to be within 14, either above or below from the regression line. On some rare occasions, they're about 2 standard errors away. In fact, I'm going to specially draw the lines that you would have if you went 2 standard errors above the regression line or 2 standard errors below the regression line. Not because this is something you need to do, but I want you to understand and see what it does. There is the upper and lower lines of where the data should be. Can the data go outside these bounds? Sure, but it's rare. Going out 2 standard errors captures about 95% of the data, so 5 times out of 100 a dot will escape this. These are called prediction bounds. Where should my prediction lay? And that helps you get an idea of what these prediction bounds are telling you and what this 14.02 tells you. This is how accurate your regression line is. In other words, how far away the data can land from the regression line. Now, we're leaving off a few important details. For example, this number here, which is the error in the slope, should be accounted for. If we were in an upper division stat class, such as regression, we talk about how you square the errors and add them together. In this class, we make sure this error is always so small that it doesn't really matter a whole lot, 0.08 compared to 14. So this is always the error of highest importance. So when you talk about how accurate your predictions are, it's okay to just use this number for now. And in later classes, it'll get more precise about how that calculation goes.